Hey, good morning, guys. Maybe it's the afternoon, whenever you're ready to roll with the video today. This is the video for Wednesday, March 25th, lesson 7.2, similar polygons. This will be your lesson for today to work on tomorrow and Friday if you need it. So let's get started. And page 469, and let's start at the top of the page. Identifying similar polygons. Same shape, but not necessarily the same size. Okay, same shape, not necessarily the same size. And so we see the key concept top of the page where we see all the notations on the figure. So we have a polygon, a quadrilateral in that figure, and we notice that each angle is corresponding to another angle in the other polygon. The corresponding angles might have 1, right? Might have 2, 3, or 4. Okay, so they might have any of those. That represents that those angles are congruent in those two polygons. Again, with the sides, same thing. You may just have a one notation, one little segment that will correspond with the corresponding side on the other rectangle. So as we look at that key concept, look at when we see similar polygons. Okay, when we see similar polygons, we look at the designation of similar triangles looking like this. Okay, when we have a corresponding angle, we're going to use this notation to notate corresponding angles. All right, so taking a look at the bottom of the page, 469. As you write the polygons, you want to make sure that the corresponding sides of polygons are in the same order. Okay? So if we have two polygons and they're similar, we have A, B, C, and S, T, U. If we say they are similar, we want to put A, B, C, okay? We want to say A, B, C, and when we're doing the whole triangle, it's a similar to S, T, U. Okay, so they're in the same location on the notation. Okay, B would be to T and C to U. So we see that at the bottom of page 469 in terms of looking at the similarity statement that is notated there in example 1. So take a look at that. We also see that we also have proportional sides. Okay, proportional sides, right? AB would be proportional to ST. So this side, AB, would be proportional to this side, ST, as AC is proportional to SU. So we could put that is to ST. That's going to be an equal ratio as AC over SU. So those are going to be proportional ratios. So what we learned in 7.1, if you cross multiply, you're going to get an equivalent equation if you look at that. Okay? So we look at example 1. We're just talking about proportions, right? They're proportional, and each angle is going to be in the same spot as the corresponding side in the other similar triangle. All right, turning the page to page 469, we look at a scale factor. We have a scale factor. Let's use our same triangles here. we know that ST is going to be corresponding with AB. If AB is 10 and ST is 5, we see that this triangle, each side of that triangle, is going to be proportional to this side. So the ratio of 10 to 5 is going to be the same as AC over SU. So for instance, if AC was 16, we see that AB is 2 to 1, right? 2 to 1. If this is 16, this would be 8. Okay, we could figure that out by saying 10 to 5 is the ratio of these two. It's going to be equal to 16 over, if we didn't know that was 8, or it was a more complex problem, we could put that as x. And again, we cross multiply, and we come up with x equals 8. When we look at it, we see that those two ratios are proportional. Okay, those two ratios are proportional. Okay, so if we were comparing ABC to STU, the ratio would be 2 to 1. If we were comparing STU to ABC, it would be 1 to 2. So when you look at finding that scale factor, you want to simplify it down as far as you can go. Okay, simplify it down as far as you can go. And so example 2 shows you what those examples are. So let's read guided practice 2, bottom of page 470. Determine whether the triangles shown are similar. If so, write the similarity statement and scale factor. Explain your reasoning. Okay? So what we're going to do is we're going to look at the corresponding sides in guided practice 2. Okay, guided practice 2. We're going to take the largest side of each triangle and put it in the form of a ratio. The first one in NQP is the largest angle is 15. The other one is 12 in the other triangle. Okay. We also have the second largest side would be 12.5 over, this one would be 10. Okay? So if we multiply those together, we would have 150 equals 150. Okay? We also have a third side. The smallest side would be 11.5 and 9.2. Okay? 11.5. We could cross simplify those. 10 times 115 would be, or 11.5 would be 115. When we multiply 10.5 times 9.2, okay, we also get 115. Okay? We could also put it in the form of a decimal. So if we just said 15 over 12, okay, we could put that in a simplified form of a fraction, which would be 5 over 4. This would be 5 over 4, and each of them would be 5 over 4 if we simplified it down as low as we could. We could also put it in a decimal, okay? We would also come up with a decimal. That would be 1.2, that would be 1.2, and that would be 1.25, excuse me, 1.25 on those three ratios there, okay? So now we have also the scale factor. So this would be the scale factor of 5 to 4, all right? And so we basically would say, yes, they're proportional. Triangle NQP, NQP congruent to triangle. What is it? RST. So that would be the similarity statement right here. Once we proved that they were the same ratio, that all sides were the same ratio, then we know that they're going to be similar. All right? We know they're going to be similar. In example 3, looking on page 471, okay, 471, all we're really doing now is we're given equations. Okay, instead of just giving numbers, we're now adding variables, having to solve for the variables. So take a look at guided practice 3A and 3B. Okay, 3A and 3B. We see that JLM and QST are congruent. Okay, we see JLM, QST, these are triangles, are congruent, and we're given the side lengths. Okay, so JL, we're shown, is 3y minus 2, and QS is 5. Okay, excuse me. QS is 5. We know those are corresponding sides based on the similarity statement. All we do is put those equal to each other. Okay, 3y equals 7. Y equals, what do we have? 3y minus 2 equals